is what I was just telling Monty. When we look at this particular section, there is one distinct difference between what we did on Thursday and Friday, or maybe on Friday, and then what we're doing now, okay? When we look at this section, we are getting into still doing the T-chart calculations like we did. But now we want to figure out, if we understand the concept from chapter 8, that I start with reactants and I'm making products. How do those reactants interact in order to make the product?
Chemically.
They do chemically. But that's right. But one step further, do you feel like when we were talking about situations, do you feel like all of the reactants are gone every time?
No.
They won't be. Do what?
Spectator.
Okay. Could be. So, don't let them be mad at you just because you know what's going on. Okay? When we talk about these things, I always introduce this in the same format. So, let's pretend like I'm going to make s'mores. Okay? So, if I have s'mores, let me add a page in here.
That's all Damien takes away from today.
And that's where I'm going to now. We are going to look, when we consider a limiting reactant and an excess reactant, we are going to look to our balanced equations that we practiced with in section 2. That tells us our recipe, if you want to call it that. Okay? And so I've had several years in the past, not consecutively, but for some reason, sometimes you guys have a great difficulty catching on to this. And so that's why I used a s'more example, because everybody's made s'mores, or you've at least had one. So when you think about the s'more example, you're thinking to yourself, cracker, chocolate, marshmallow, cracker, right? You have that in your mind. Once those things are gone, you can't make a s'more, because that's not according to the recipe. So when we look at these balanced equations, I want you to have that s'more thing in your mind. What am I running out of? What do I have extra of? And so then you can figure out how these calculations are going to make sense. Okay? Same exact calculations we did in section 2. Now we're just figuring out what is halting our process. Make sense? So let's look at the scientific stuff of it then. So we've already talked about these definitions. A limiting reactant is a reactant that, here's a news flash, limits the amount of the other reactants that combine to produce a product in your chemical reaction. Layman's terms, it is used up and stops the reaction. Once the limiting is gone, nothing else happens. Okay? So the substance that is not used up completely is called the excess reactant. And when we say excess, you should think of extra. You have some left over. So here's my beginning example. Consider the reaction between carbon and oxygen to form carbon dioxide. According to the equation, 1 mole of carbon reacts with 1 mole of oxygen to form 1 mole of carbon dioxide. So it says here, suppose that you mix 5 moles of carbon with 10 moles of oxygen. And we can look at this diagram to see if I actually have all of those things to come together. Okay? So what was your proportion for carbon dioxide? When 1 mole of carbon and 1 mole of oxygen come together, they make 1 mole of carbon dioxide. So here's the thing. Think about how that they come and match up. So we're not going to do this every time. We're just getting a visual with chemistry stuff. So we've got this one that matches up with that group. Okay? Is that true? We've got one that matches up with this one. Then I can say this one and this one and this one. So do I have some that are not matched up? Yeah. So in my mind, I'm thinking that I'm going to use all of my carbons. What do I call those? Have I used all the carbons? And they're occupied. So this one is what we call limiting. Okay? Do I have extra oxygen molecules left over? What do I call those? Excess. Okay? This is why I didn't want you to think about the silly thing about, well, I can just make a s'more with 2 marshmallows and a piece of chocolate in between. Because that's not a real s'more, right? I'm just not going to willy-nilly put these other molecules together and just, call it carbon dioxide for the sake of carbon dioxide. Right? So, notice what we have. This is kind of what Clay and Skylar were talking about. These extra molecules, what are they doing? I mean, they're not called spectator ions. They're not called spectator ions because they're not charged, right? They are excess. And how is that shown in my diagram? They're just by themselves, right? They're just there. So in the process of looking at those things, I produce my maximum amount of carbon dioxide, which is 5 molecules of it. Agreed? But I have extra extra oxygen molecules left over that they're not doing anything, just they're present in the reaction. Okay? So that's what it's talking to you about in this bottom paragraph here. If I'm going to use an example like this, let's talk about what my recipe, if you want to call it that, is for s'mores. Okay, so I've got to have 2 graham crackers.
2 grams.
And we're going to say 2 let's just say pieces of chocolate.
Hershey.
Okay? And I'm talking about 2 of the little rectangle pieces, okay?
Oh, not a whole bar.
And then 1 large marshmallow. That's my recipe for s'mores. Do we agree with that?
Yes.
But let's say what I'm given, whoops.
Oh, no, it was mine.
Random line.
Whoa.
And this is the way that this is going to be told in the problem. Let's say that you are given 3 crackers. I'm going to make this first one easy. 2 pieces of chocolate. And 1 marshmallow.
Simple.
And it wants to know, here's your terminology,
One more.
which one is limiting. And this is what we think about it as. If you go back to that previous page, the definition of a limiting reactant, and we're going to say that these are all reactants up here. These are my reactants because over here, what do I produce when I put all of those things together?
Product.
I produce 1 s'more, right? So in the process of thinking about what you're starting with, kind of like a synthesis reaction, we start with all 3 of these pieces, we put them together, they're one thing. Of the givens that we have written here, which one is going to limit the amount of s'mores that I make? Well, compare what you have to what you need. So if I look, do I have enough marshmallows?
Yes.
Yeah, I have 1 marshmallow. So that's good. Do I have enough chocolate? I need 2 pieces. I have 2 pieces. So that is also good. Do I have enough crackers?
And then some.
Yeah.
Extra one.
And I can also say that I have extra crackers, don't I? So this is what we're going to call our excess. Why are we saying that that is an excess?
It's more than.
You have more than enough.
I have more than I need. So here's the question I'm asking. If I have one thing in excess, am I going to run out of that one thing?
No.
Am I going to run out of the other two things?
Yeah.
I'm going to run out of the chocolate and of the marshmallows, aren't I? Because I have exactly enough in order to make my one s'more. So that's what I was going to ask. Aren't these two things limiting your product? Because once I use those, I don't have any more, right? Okay, so let's look at this as in a different way. Let's say that I am given okay, so this time I'm given 2 crackers, 3 pieces of chocolate, and 3 marshmallows. Well, so if I look at what my reactants require, I have 2 crackers. Is that enough or not?
Yes.
Yes. Okay, so what about the chocolates? Do I have enough?
Yes. Excess.
And do I have some left over once that's gone? I'm only using 2 of them, right?
Your attention, because at the time change, the clock on the bell did not reset, so you'll have to dismiss your class and watch the
I
clock.
see where she gets it. That's actually not his room.
Okay,
I would.
so if we look at it this way, we've got 2 crackers, which is exactly what I need, right? And then after I pull from what I have 1 piece of chocolate in excess and 2 marshmallows in excess. Agreed? So let me ask you this. Once I use all of those and they are gone, what happens to your reaction of making a s'more? How? Huh? I don't have any crackers, so therefore I cannot make any more s'mores. So are you telling me that in both of those processes, the first example and the second, the things that I said were in excess, when they are used up, are you telling me that the process of making a s'more halts? It stops completely?
Yeah.
Because once I use those things, I can't make any more s'mores. Agreed? Once on this bottom example, once I use my graham crackers and those graham crackers are all gone, I cannot make a s'more with 1 piece of chocolate and 2 marshmallows. Right?
3 pieces of
No, don't go there. Don't try to be cute. I'm trying to get this across to you. Nope, that's not the recipe for making a s'more, so we can't do it. Now, when we talk about this, look up top. When I use my limiting, when I used all the chocolate, all the marshmallows, can I make a s'more with 1 cracker?
No.
Mm-mm. So, when we look at those things, the purpose of a limiting reactant is to stop the reaction. Because once the limiting thing is gone, there is no more reaction to occur. What about your excess? What do you think it's going to do? I mean, it's just going to kind of like what Clay was saying about the spectators. They stay behind, don't they? Are they still going to be in reaction? Yes. So, but they're not doing anything because there's nothing else for them to do. Okay? Yes.
So to find the
So let's talk about a real sample problem. Okay, this is your job to tell me for sure here. We're fixing to do a calculation. Do you want to go all the way through this one that's already worked out for you? Or do you just want to go ahead and do the sample problem A on the next page and work it out step by step as we talk about it? Do the do the sample problem? Okay, go over to sample A.
Way to make Miss Marlin's life hard.
So this is the problem. Let's do A and do it as it's listed out here, because this allows us to think about what steps that we have to do. Then I'll go back and we'll work one by ourselves, maybe.
Nah, I know.
I don't know. We'll see where I can find one. Okay. So it says some rocket engines use a mixture of hydrazine and hydrogen peroxide as a propellant. The reaction is given by the following equation. So they've given that to you. Remember, what are the two things that we looked for in section 2 before we could do any calculation? Do I have a chemical reaction, and is it balanced?
Yes.
Do I have those two? I do. So problem A, or question A, says which is the limiting reactant in the reaction when so many moles of hydrazine are mixed with so many moles of hydrogen peroxide? And then how much of the excess reactant in moles remains unchanged? So here's what we're doing. Problem A, we're doing a calculation to know which one is going to run out first. Then in problem B, we're doing a calculation to see which one, of the one that's excess, how much is left over, like those 5 moles of oxygen gas that we saw in the diagram. So do you have a visual for what we're doing? Okay, so this is the part that I was talking about Monty asking me earlier. When I look at this question, there's one difference between the two sections, section 2 and then this section. Notice in problem A, how many given quantities do they list? 2. I'm told that I have this many moles of this reactant and this many moles of that one. How many givens did you have last section? 1. How many givens are you going to have tomorrow? 1. You're taking section quiz over section 2. Okay? So when you get into the limitings, they're giving you 2 quantities because they're asking you how many of those things are used to completion, how many are left over. Do we see the difference in the 2 sections? All right, so let's just say what is given, and we just talked about that. Well, I'm given this many moles of N2H4 and 0.500 moles of peroxide. So what is unknown? What's unknown is the limiting reactant. So here's where it's pushing us to look at. In the box here, it says what quantity of N2 is produced by this much of that hydrazine. Where is N2 in your chemical reaction?
The product.
On the product side. So here's your plan of action. You choose one product to look at. Okay? When I have that one product to look at, then I'm going to say of this one, how much of the nitrogen can I make from it? Of this one, how much of it can I make? You're comparing both reactants to one product. Okay? So let's do that first, and then we'll talk about why we did it. So if I were to say I have my day can be complete because I do that at least once a day. All right, so if I have 0.75 moles of N2H4, how do I get over to the nitrogen gas? T-chart. I have to switch from compound to compound like I did in section 2 when I have what magic unit? The magic unit is moles. Magic and mole start with M.
Go. Oh, my
Okay.
dyslexia.
So, I'm starting with my T-chart, and I want to switch from N2H4 to the nitrogen gas, correct? So that means moles of N2H4 go on the bottom of the fraction. Moles of nitrogen gas, which is N2, goes in the top of the fraction. Sorry, you guys in the back. All right, so now you tell me. I can't show you the problem at the top, but I've got moles here. I'm using a mole ratio in my fraction. Moles over moles. So where do I get my info from? From the balanced equation. So if you look up in your balanced equation, what number is in front of the hydrazine? N2H4. 1. So I'm writing it in. I got 1 mole of that. What number is in front of your nitrogen gas? 1. Hopefully you don't have to use a calculator on this.
Wait,
So in the process of that ratio, how many moles of nitrogen gas are you going to produce from that amount? 0.750 moles of N2. Okay, so now we don't have anything to compare it to. So let's use the other reactant as a comparison. So I'm going to do the same exact process, but I'm starting with my different reactant. What would happen if instead of mole quantities for my givens, what if they gave me gram quantities?
there you go, Grandma.
I've got to go from grams of my given to moles of my given, right? So now that I have 0.500 moles of the hydrogen peroxide, I'm going to moles of nitrogen gas. So what am I doing?
Well, you gotta go from grams to moles.
I don't have grams. That was just a hypothetical.
Oh,
I've got moles. So moles of the hydrogen peroxide go on the bottom, and moles of nitrogen gas go on top.
so we gotta
Be honest with yourself. Do you understand why we did it that way?
Yes.
Okay, so if I have a mole ratio in my fraction, what numbers go in the fraction?
2 on the bottom.
Okay, so what number goes? Danny said 2 on the bottom. Is that right? What number goes in the top? 1. Then I check to make sure that my units cancel out, and they do. So I have 0.5 times 1 divided by 2. 0.25, thank you, Shane. Moles of N2. So here's the point that I wanted to make. We started with 2 reactants, correct?
Correct.
We did a calculation with both of those reactants to figure out how much of one product would I make. Which one of those reactants produces the least amount of the product? So what is smaller? This number or this number? What's smaller? The bottom one. Yeah? So which reactant produced the least amount? That one right there, right? So wouldn't we say that the H2O2 is limiting? Why?
Because it
Produce the
didn't,
least amount.
Produce the least amount.
and it produced less than it was.
Produced less than it already had. So here's the thing that I want to show you guys though. When you do this, a lot of times you guys will tell me that N2 is limiting. Because 0.25, you produce that much nitrogen gas. Why can N2 not be the limiting reactant?
What's the product?
It's a product. So go back up to your question here. This is what I always do. When I figure that out, I actually write in that this is limiting and this is excess. And I use the abbreviation, so, you know, because I know how worried y'all are about conserving lead. Limiting, excess. Hopefully, I would know if I went over here and tried to write limiting reactant, I would hope that you would catch yourself, because this is on the product side of your reaction, right? I know you don't think about chemistry all day, but I hope when you kind of walk in that you kind of get yourself in the mindset, right? So, when we look at that, we're identifying that H2O2, when it is used, it's gone. So if it's gone, that means now I want to figure out how much of that is left over. Do we agree with that? So now let's go to the process that we have to finish up with. It says, using the amount of limiting reactant calculated above, find the amount of excess reactant that is used in the reaction. This is how I do this. If I know my limiting amount of product being made, yes? Why don't I go from my limiting amount of my product to my excess reactant? Because that ratio is going to tell me how much I used, okay? So this is what I do in these. This is just because this is the way that my mind works for it. So I'm going to show you what I do as the calculation. If I have this much nitrogen gas produced, let's figure out how much N2H4 is used to make that. So I'm going to use moles of nitrogen gas on the bottom and moles of N2H4 on top. Yes.
What's that right after NP?
Product, PDT. So we had 0.25 moles of N2 produced at the most amount that it can make. Because once that H2O2 is gone, it stops, right? Isn't that the definition of the limiting? So now we're figuring out if that's the amount that halts the process, how much of that N2H4 was used to make that. So look at your ratio again. If I look back, there's a 1 there and a 1 there. In doing that, I'm showing myself that I use 0.250 moles, and I'm going to write that behind it, used. Right? That's how much was used to make that product. Let's do a little bit of subtraction here. I had 0.75 moles of N2H4 given. Isn't that what I started with? I had 0.250 moles used. So here's my scenario. Maddie's going shopping. I'm her mom. I give her $75 to go shopping with. She goes shopping, because that's what I'm giving her. She goes shopping. She doesn't find anything that she likes, except for one item. She spends $25 of that $75. How much did she use? 25 bucks. So does she have any of the money left over that I gave her? How much of it? 50 bucks. How did you know that it was $50?
Subtracted the.
Subtraction. I had what I was given. I took away what I use, and I'm left over with so much, right? Same exact process here. 0.75 moles available, 0.25 used. So therefore, I know that I have this much of my limiting or my excess reactant left over.
Why do they put a third zero?
Sig figs.
I never understood those.
Sorry. I gotta get by this.
Oatmeal.
Cream of wheat. No sugar in it. Hmm?
That's 844.
Okay. Good time.
Hey, I wouldn't mind this next area.
Hey,
You don't tell all.
y'all do this for practice for your quiz.
Is this gonna be on there tomorrow?
So
No.
it's like not homework.
But the stoichiometry is
You said we're gonna have 4 of them?
4. All right, guys, listen. Here is your practice problems for this.